There we go. Yeah, so apparently the UVA Wi-Fi on Wabash's campus is better than the Wabash Wi-Fi on Wabash's campus. Fitting. Okay. So, nice. I'm glad people are in the chat. It was very, very quiet in my algebra class. Okay, so plan. I mean, this will take a little bit where I just talk about what the heck is going on, and then I'll open it for questions. So plan right now is, I guess, the first thing that I'm sure you care about is test postponed for near future. I don't know what's going to happen right now. My other classes, online tests or like take-home tests make a lot more sense. Calculus is a lot harder to do that for. And so I don't know exactly how to do that right now. We're kind of talking about that. I need to talk to Pofald and maybe Dr. McKinney as well because he's doing Calc 1. And the BSE for now is also postponed, I guess. And we're not really sure if, because I mean, we also would have retakes, right? And like, how the heck are we going to do like potentially 3 retakes for that? So yeah, not really sure what's going on with the test right now. But I will continue to communicate with you on that. With that said, there could be potentially more weight on a project down the line. We're going to have a project anyway, but it's definitely not going to like replace all of the tests. So, I mean, either way, like our syllabus is just like a piece of trash right now. Things are just going to be very different. So homework wise, I mean, I'm still planning on having class preps, still planning on doing class prep videos, potentially more videos, depending on like how the actual class interaction goes. And if you guys are having like specific problems with certain questions on homework or like certain topics from class, I can maybe do some short videos, maybe more like the 5-minute variety or something, where I just like do an example on a topic or something like that, if there's like strong desire for it. So class preps will basically proceed as they were, and now homeworks basically will be like the class preps in terms of submitting them via PDF for me to grade, because there's no way to do it in person. So the homeworks may be a little less challenging. I'm not going to say they're just going to be super easy, but some of the harder questions where I kind of expected you to come to the office with questions, those may be gone now, just because I'll still have office hours, but they just may not be as effective, obviously, as doing things in person. So office hours, I also probably won't be as available, just because I can be in my office and do other stuff, and you guys can like walk in, but I can't just always be on Discord and Twitch at all times. So that's just like not super reasonable for me to be available at all hours. So like the actual posted office hours on my syllabus, yes, test postpone. We don't know for now what the plan is. I'll send out an email with kind of the logistics stuff later. But yeah, in general, just not sure how a test would even look right now, so I need more time to think. Yeah, no problem. Who is that, by the way? It's a cool name. And okay, cool. So yeah, office hours will be definitely the like scheduled ones. So like I'll have office hours from 2 to 3 here after class. I'm not sure how much you'll want to ask at that point, but feel free. And then the plan is I'll just kind of bounce between my 3 class servers, and there we can also do like a direct chat if you want to like share your screen with me, or I could potentially just like still stream on Twitch, but like not save the videos. And like if you guys join the voice chat here, like you won't show up on Twitch. It's just my mic. So you would be anonymous in that way. If we were on just like our own server or doing like a a chat where you just invite me and we do like a private chat. So you would only hear me talking on Twitch and not you, and you would only see me writing and not you. So that's kind of what I'm thinking for that. And we can work things out if you guys have better ideas. I know topology, we're trying to get kind of like a free universal whiteboard where like everyone in class can write on it, which, you know, could partially be disaster because of that, but also if people are mature, it could be kind of useful. But I don't have a very easy thing to write, like using my laptop. I much prefer writing on my iPad, so this is easier for me at least. Other things. Yeah, I mean, until we figure out a test, like I can do a review session and it would basically be just like a live stream. Again, Rippy is in topology, yes. And, you know, we can talk about that more when it comes, but like we can still definitely do a review session together, and it would basically just be like another class, I think, in terms of format. So that's kind of the plan right now. Things will be obviously a little bit less collaborative, just because it's going to be hard for you to like share screens with each other. That's the big issue, right? Is you can't really see what you guys are writing. So if we find out a good, efficient way of doing that, then that would be cool. Otherwise, it will be a little bit more of me lecturing, but like absolutely please hop in the voice chat or text chat and ask questions, and I will try to respond, and we'll have it be as interactive as you can kind of make it. But, you know, we'll just try to go through the worksheets. I already post solutions to those, but I will do so like more quickly, I guess. And I'll probably post the notes, like export them from my iPad as well. So I've got, you know, my notes folder over here that you can see. And yeah, I can just kind of post those for you guys to look. And Twitch naturally records everything. So you can go back and watch the VOD if you so desire. Questions about anything logistically? Yeah, we can make that due Wednesday with an online submission. Because there's no point in doing it early for feedback for the test that isn't happening. So yeah, I'll fix that here momentarily, or like after class probably. Yep. But I looked into a program called Zoom. First of all, you could just say Zoom. Yeah, I've thought about Zoom. I have not. I'm much more experienced with this, and I'm also concerned about the fact that we only have so many Zoom licenses on campus. So if everyone tries to go Zoom, that could be a real problem. But it is something I'm going to look into this evening, because I know, like, you guys, I could see you as well as you can see me. And I know there's like a screen share. I'm not exactly sure how that works because I haven't done that before in Zoom, but somebody mentioned that earlier, that you could do some sort of whiteboard kind of thing. So yeah, this is definitely not set in stone. Right. Yeah, so I mean, my main motivation the rest of the semester is to get affiliate status on Twitch. So, you know, may not go Zoom, but no, I will look into it, because that would be nice to be able to see what you guys are writing just as much as you guys can see what I am writing. What should we expect if we have to stay online past 2 weeks? Yeah, I don't know. Not sure. I need more time to think about what a take-home type of test would look like for Calc 2. Mostly because I do expect us to stay online past 2 weeks, to be honest. I don't have any like information on that. I mean, what you have is what I have right now. But I absolutely think that we're going to be online for the rest of the semester, in all honesty. What do you mean in terms of credit? Like, that even people who don't want to CC would just CC it because it like becomes not a real class or something? I have not heard anything about that, and I think that that is untenable, to be honest, because then you would have a bunch of seniors like not graduating if they were like forced to CC. And if you only did it for seniors and allowed them to get grades while everyone else, like that also is like not going to happen. So I don't really think that's likely. I think the classes will just look different, but I think grades will proceed roughly normally. It is a terrible time to be a senior, yeah. It's rough for a lot of reasons. Other questions? I mean, I cannot even guarantee that we're going to have a BSE at this point. I've not talked with Pofald yet, but I have talked with Dr. McKinney quite a bit, and we are not convinced that it's going to be reasonable to even have one. Yeah. So yeah, I mean, the second that we know more, I will definitely communicate it with you. But for now, like all tests are postponed, and we just like don't know. But yeah, homeworks should be roughly the same. I mean, posting PDFs because you guys already do that for class preps. I mean, that should be pretty reasonable. And I mean, obviously, office hours won't be as good as in person, but I think we can like make it work well enough. And obviously, oh yeah, and so like in our channel, right? Like use the working together thing. You guys can talk with each other. If you friend each other, you can share screen in Discord or do a video chat in Discord or both. And so you can work with each other pretty easily with that. And there isn't a reasonable limit on that. So they extended it from 10 to 50 people, like because of the virus. So you shouldn't run into any limits in terms of population on a call. Yeah. So yeah, I mean that's pretty much the plan right now. And like I said, I'll send out an email later with like logistic things that we talked about. But any other questions before we kind of do math? The screen in front of me is Discord, so I guess I prefer text on there. But like I mean, you keep seeing me look to the side, so like I will look at Twitch chat. I mean, it's up to you in terms of questions. I guess if it's one that's gonna like interrupt me much, or maybe like put like I have a question and then like come in and unmute yourself or something. But yeah, I mean, if I pause while talking, feel free to ask questions like with your mic in the live stream. I'm perfectly fine with that. Or if you type it out, I'll read it and then answer it. Either one's fine. I just know that some math questions are really hard to type out. So, I mean, I think it's pretty reasonable to use your mic. Ready to go? Okay, so like, do you guys have Canvas pulled up? It's not a huge deal if you don't, I guess, but yeah. Do you have that up? For like the 11.6 worksheet? Okay. It's fair. Yeah, it might just help to follow along. You know, I looked at the class preps, and there's one thing I wanted to talk about. Or maybe two things, I guess. So I wanted to talk about 9 first, because 7 and 8 kind of lead into things. And it's basically 7 and 8 are essentially wrapped up in that box at the top of our worksheet. Yeah, I wanted to talk about 9 because I saw some very different things on there. So we have this series, which I didn't put in display style, and so it looks awful, and I hate it. Wow. By the way, I have a new pen that's literally at my house now, and so Wednesday, I guess I will be able to write much more efficiently. This one is not terrific. Right. So I saw a lot of different things for radius and interval of convergence here. So factorial is what? Yeah, it's number 9. So factorial grows really fast, right? And we know that like something over factorial then like goes to 0 super fast. It like definitely converges, you know, and so on. And in this case, it would have a radius of, well, it would have infinite radius. It would converge everywhere. But if it's being multiplied by it and not divided by it, then we should think it's going to like grow, and we might worry that it diverges almost everywhere. And if we do the ratio test here, right, so you're going to get k plus 1 factorial x to the k plus 1 over k factorial x to the k. This is nice. I don't even have to multiply by reciprocals. And we get this guy. So we get a lot of cancellation, right? So we can cancel this with this. We're left with just 1x. And then we cancel this factorial because it's k plus 1 times k factorial. And so we're just left with the k plus 1 up top. And so then we just get the limit as k goes to infinity of k plus 1 times x, or the absolute value of x. No matter what x is, right? So, well, sorry, if x is 0, it's going to converge, right? Because you would get 0. But if x is bigger than 0 or smaller than 0, then the absolute value is positive, right? Strictly positive. And in that case, you have something, it may be really small, right? Maybe like 1 billionth. But as k goes to infinity, k plus 1 is going to be big enough that the product will go to infinity. And so if x is not equal to 0, this limit is infinite. And obviously that is bigger than 1, right? And so by the ratio test, this would diverge. So basically what we're saying is the radius here is 0. And so it only converges at the center. So we have like a completely, no width to our interval, I guess is what you would say. Which again should make intuitive sense because you're multiplying by something really big, or something that gets really big in k factorial. So I saw some different answers for that one and thought that was worth talking about. So we've now seen all 3 cases where it converged everywhere, right? We saw the one like e to the x, which is x to the k over k factorial. That guy converged everywhere. Right, we have this guy. This converges on negative infinity to infinity. If you multiply by it, it converges only at 0. And then if we did like the geometric series, then, I guess the geometric with radius r. Then we get negative r to r. So we can basically get any of these three, and that's kind of the only three that are possible, right? And they're all symmetric about the origin. All right. So then the main stuff that we were doing in this class prep with regards for today's stuff is the stuff in the box at the top of 11.6, right? So essentially what we see here is you can take the derivative term by term, right? This is the nice thing about having a polynomial, right? You look at e to the x, and we found out that its power series is over 2 factorial, x cubed over 3 factorial, which is 6, and you keep going. Then if you take the derivative, well, I mean, this is an infinite polynomial. You just have to do the power rule every time. That's super easy and super nice. And, well, what do you get? Well, this guy becomes 1. This guy becomes x. This guy becomes x squared over 2, right? We multiply by the 3, which cancels out with the 3 down below. And then x to the 4th over 24 would become the x cubed over 6, and so on. And so you get the same thing back, which is obviously what we would hope, because that's true for e to the x. But this is often an easier way to view things, right? If you have some like really weird function and you turn it into an infinite polynomial, its derivative or integral may be much easier, right? And you can do either of them just by doing them term by term, right? You just do it one at a time and you get a new infinite series. So the other key thing is that they have the same radius of convergence, right? So this worked everywhere. This one, e to the x is negative infinity to infinity. For like geometric series, right? So if we just had the x to the k, for instance, and not over k factorial, right? This is 1 over 1 minus x, but only on negative 1 to 1. And so when you integrate that, right, you would get a denominator, right? So you'd suddenly get x to the k plus 1 over k plus 1, and start at 0. K equals 0. This would be the integral of 1 over 1 minus x dx. And here you'd have to check the endpoints. So it'd be still like negative 1 to 1, but then these two guys you'd have to like worry about suddenly. And that's where you'd, again, you know what these terms look like. You could do, well, you can figure out what this actually converges to and see what happens, or you can look at what this series exactly would be by plugging in 1 or plugging in negative 1 and see what really is going on. And in this case, we're going to get something different, right? Because we've added a denominator here. So I can even show that, for instance. I see some typing. Or all of your... Yes, they will. So that's the nice thing about Twitch. These things naturally save. So you can just go on the Twitch channel and watch the VOD. Yeah. Right. So this one, for instance, so like if I plug in negative 1, what happens? So I get like negative 1 to the k plus 1 over k plus 1. What kind of series is this? Someone type that out or say it. Yeah, it's an alternating series, right? And the terms are going to go to 0 because of exactly this k plus 1 down here, right? And so this guy is going to converge. So really, this is an included endpoint. And then if you do the other way, right, and you plug in 1, well, then it's just 1 over k plus 1. And it's essentially the harmonic series, right? So, I mean, you can't do a direct comparison because plus 1 versus minus 1, but you could do the integral test, for instance, very, very quickly and see that this diverges. And so the correct answer for the integral one would be it converges on -1 to 1, but it converges at the left endpoint, but not the right. Okay. So basically you have the same radius, but the endpoint stuff could be different after taking the derivative or taking the integral. So that's the only stuff that can change. You can ask a question with the mic if you want. I just see typing. Okay, so can I explain why I'm using brackets? Yeah, because it converges at that point, right? This is my interval of convergence, and so like if it does converge at that point, I do want to include it. And so the one on the right, it diverges, so I do not have the bracket there. But for -1, right, that gave me the alternating series here where it does converge, so I do want to include that point. Okay, so now let's look at the actual worksheet. Okay, so this is one we have seen before, and we'll talk more in 11.7 about how we actually get these things. So like Taylor series are a good example of how to actually come up with a power series that represents your function. So sine of x is you basically get all the odd pieces of the e to the x series, but then it's also alternating in sign, right? So looks something like this. Maybe I'll write one more term. Next one would be plus, and you keep going. And so how do we get sine of x squared then? Well, we kind of did this already. Okay, about the limit. What do you mean by guess the limit? Ah, yeah, we'll get to that with this very next thing. So, all right, I guess I can answer that now. Yeah, I'll answer that now, I guess. There's not really an efficient place to put this. So, okay, I'll just kind of break this off. Right, so let me look back at exactly. It was the 1/1 minus x one, right? Yeah. So 1/1 minus x was this guy. And then we said that this one, or hopefully what you saw, was, wow, this k times x to the k minus 1 looks an awful lot like I just did the power rule on every term, right? And so if I had to guess what happened with this series, and you could start this, by the way, at 0 too, it's just that the first term would be 0, because, yeah. Anyway, we start at 1. It would multiply by 0 and not be too big of a deal. But, right, we're just doing the power rule every time. And so if I had to guess, if I took the derivative term by term of something that gave me 1/1 minus x, what do you think it's going to be? Well, you know, our guess here would be, it would be the derivative of 1/1 minus x, right? And, you know, you just do the chain rule really quick, right? This is 1 minus x to the minus 1. So you get it to the minus 2, so 1/1 minus x squared. But then you also have derivative of the inside, so it's -1. So this is what the limit should be, and this is true, right? So this is what's in the box up there, that the derivative of that function is the derivative term by term. And so you really do get this. So it's not just a guess, it actually is true. So, right, back to sine of x squared. So with sine of x squared, right, we did some stuff with like the 1/1 minus x, where we replace the x with an x squared or a negative x to get like 1/1 plus x or 1/1 minus x squared or something. You can do the same thing here, right? So like we have a series, And, this is putting in x. Well, let's just put in x squared every time we see x, right? So this is x squared minus x squared cubed, or x to the 6th over 3 factorial, plus x squared to the 5th, or x to the 10th over 5 factorial, and then x to the 14th, and so on. But we can also use, right, like summation notation, which can be a little more helpful, especially if you want to know where it converges, right? You would like to know, okay, I can use my ratio test, figure out my radius, because you can't just like eyeball this and say, oh, I think this converges here, right? You can't get that from just looking at these terms. You have to do the ratio test. What's up? Yes, Reese, this is a Maclaurin series because it is centered at 0. But yeah, we'll talk about Maclaurin and Taylor series more in 11.7. Okay, so how can I write that sine of x guy? Yeah? One is talking about like multiplication on the outside, right? So it'd be sine squared of x would be sine of x times sine of x versus sine of like an input squared. Right, so like if x is 2, this would be sine of 4, and this would be sine of 2 times sine of 2. And so like the reason that I even brought this one up in general, right, is I think we talked about this improper integral a while back as one that was impossible. So I'll just put tough, but that's really an understatement. We straight up can't do it with any of our methods, and you can't get it in terms of like nice functions, right? Elementary functions. So you can't write it in terms of exponentials, logs, inverse trig, etc. And so one way to get around this, right, is to rewrite it as a series, and then you can integrate, right? So first of all, let's look at the sine x one. So this was all odd powers of x. So the way I would write this would be, well, first of all, our first thing was positive. So negative 1 to the k works since we start at 0. So it's going to be every other starting with positive. And then we want x to the 2k plus 1 is a good way to get odd numbers, right? All odd numbers are one more than an even number. And in this case, we start with x to the first power. And so k equals 0 will give us x to the 1, and then it goes up by 2 every time from there. And it's switching sign. And then down below, right, we have a factorial that matches the power. And so you want 2k plus 1 factorial. And so then sine of x squared is just replace this, right? So it's the same thing, but with x squared put in there. So it's like negative 1 to the k, and then x squared to the 2k plus 1 over 2k plus 1 factorial. And then if you wanted to simplify that, then it's just 2 times 2k plus 1. And so maybe I'll just put here, this is the same as saying x to the 4k plus 2, right? Because raising a power to a power is just multiplication. Okay. So once we have this series, we can just look at our box over here. Okay, what happens when we integrate this? So you just keep the same first term, and then you just do like the reverse power rule on it, right? And so the integral of sine of x squared dx is the series from k equals 0 to infinity of same stuff, say x to the 4k. Now here, right, we add 1. So it went from 4k plus 2 to 4k plus 2 plus 1, or 4k plus 3, over 2k plus 1 factorial. That stays the same. And then since we did the reverse power rule, we up the power to 4k plus 3. We also have to divide by that 4k plus 3. And then we have a nice power series for the integral, which, heretofore was super hard to deal with. And now, right, you can just plug it in. You could get nice estimates for anything that you want. And the point, right, was that I think we found out previously that sine of x, this guy converges, I think that was 2 videos ago for like a class prep, that this converges everywhere as well. And so we would get that this converges everywhere, right? It's going to keep the same radius. And so that's super nice for us. So not only does this work, it works everywhere. So it's not like super useless. Okay. So now we have, again, I think this was, 2 class preps ago? So 1 over 1 plus x squared is negative 1 to the k, x to the 2k. So basically what you want to think here, right, is you start with 1, and then minus x squared plus x to the 4th minus x to the 6th, and so on, right? So you're just taking even powers, increasing by 2 every time, but switching signs in terms of what you're doing. And this is 1 over 1 plus x squared. How can we get a series for arctan from this? Any ideas? Right, yeah, this is the derivative of arctan, right? 1 over 1 plus x squared. And so, again, arctan is something that, with what we know so far, we wouldn't really be able to do. But if we know its derivative, then we can just take the integral. So arctan is the integral of 1 over 1 plus x squared. And so we can do something just like we did above, right? So the constant stays the same out front. We raise the power by 1, and then we divide by that power, right? And again, this is, you can figure out what we're doing here, right? It just goes up to x minus x cubed over 3 plus x to the 5th over 5, and so on. And you can either do that term by term from like the written out one, or you can figure it out by plugging in k to our sigma notation. Okay. All right. So how do we figure out what happens at the endpoints here? So first of all, we should figure out what the radius is. So we need to be doing ratio test, right? So that's why I like the sigma notation, right? We're going to have to do it for the ratio test anyway. So let's go ahead and take a look. So we've got the limit. As k approaches infinity, so I'll just put ratio test. Right, we do the absolute ratio test, so we make sure the terms are positive. So here we actually, unfortunately, do have to multiply by a reciprocal. So this becomes 2 times k plus 1, and I guess I can simplify it on the next step. Plus 1 over 2 times k plus 1 plus 1. Boom, boom, and boom. Okay. So what cancels here? So first of all, I'd like to point out, right, we should probably simplify where we can. So like 2 times k plus 1 is 2k plus 3. It's helpful to know how much you have left over. So cancellation we get, right, is first of all, these guys are gone, but they don't really matter anyway because we're inside an absolute value, so -1 doesn't matter. And then here, these all cancel, and we're really just left with x squared. So maybe I'll just make clear that stuff is canceled out, and we're left with exactly 2 powers of x left. And so this ends up being the limit as k approaches infinity of x squared. And here, even since it's x squared, I really don't even need the absolute value brackets because it's going to be non-negative, times 2k plus 1 all over 2k plus 3. Okay. What happens here? So these parts, they go to 1, right? Because, again, really it's just the 2k's that matter. And those grow at the exact same rate. And so really that boils down to 1. And so it's just the absolute value of x squared. And so when does this converge? Well, it converges if this is less than 1. And x squared is less than 1 if x is in negative 1 to 1, the open interval, right? And then, of course, the ratio test is inconclusive if it's equal to 1. And so we have to check the endpoints, which are negative 1 and 1. So we can check them separately. Okay, so again, let's remember what our thing is, right? So it's negative 1 to the k, x to the, gosh dang it, x to the 2k plus 1 over 2k plus 1. So, yes? No? All right. So x to the 2k plus 1, but this is, x is negative 1. And then over 2k plus 1. Okay, so really what we need to do is figure out, is this alternating or not? Right? Because we need to figure out what exactly this power of negative 1 is. So this is going to be the sum. This is negative 1 to the, these add together, right? So it's 3k plus 1. And then it's over 2k plus 1. And then just think like what's happening here. So if k is odd, then 3k is odd. And so 3k plus 1 is even. If k is even, 3k is even, and 3k plus 1 is odd. So this is alternating, right? It does bounce back and forth. So 3k plus 1 switches sign, or sorry, switches between odd and even. And so this is alternating. Do we think this converges or diverges then? Thoughts? What the heck did I just got botted? Feels bad, man. Yeah, it is going to converge. Right. Okay, so converges at that endpoint. And then at x equals 1, well, the 2k plus 1 thing goes away, and we're left with just negative 1 to the k over 2k plus 1. This is also alternating. And converges. So here, it's negative 1 to 1 inclusive. Okay. So again, we integrated, we got something slightly different than before. So the one with just x squared would have been negative 1 to 1 not inclusive, I believe, or at least on one of the endpoints. We'd have to go through it. But yeah, the point is the endpoints, you can have slightly different behavior. All right. So how do we do this next piece? So this is nice. We haven't really seen too much of this yet. So there are a couple ways to view it. I feel like the first thing you see when you look at this function is it looks like a U-sub kind of problem. But you don't really have to view it that way. So if I gave you a slightly different thing, Chris, you might want to mute that, by the way, if you're not asking questions. So 1 over 1 plus x cubed, this is a lot like the 1 over 1 minus x, right? This is 1 over 1 minus negative x cubed. And so if we can get this one easily, then instead of like doing any wild trick, you can just multiply through every term by 2x squared. And then that's really easy, right? So sure. Is this a good stopping point? You can go whenever. We don't have to go through the whole problem if you have a question now. X cubed, not x squared. But you can't do it to just one of the summands down below. Because it turned into like 1 over x plus x squared. Yeah. It's a good question. Yeah, so I think this is going to be the route we want to take. And so we know that 1 over 1 minus x, again, this is just the x to the k1. And so 1 over 1 minus negative x cubed should be replace every x with negative x cubed. And so this should be k equals 0 to infinity of negative 1 to the k. I'm just going to pull out the negative 1, x to the 3k. And that, right, that is 1 over 1 plus x cubed. And so if we want the 2x squared then, so then 2x squared over 1 plus x cubed is just, well, we'll just multiply this through here in 2 steps. Right, so we start with this. And this is a good trick to remember, right? You don't have to be super fancy. We just literally multiply it in. And so sum, we have a 2. We still have a negative 1 to the k. And then all we have done is add 2 to our power. So instead of 3k, we get 3k plus 2. If I can draw a plus. And then still k equals 0 to infinity. Does that make sense? So we said power series representation, and so power series don't have anything on the outside. It is like some term times x minus your center to the whatever. So you really would want to get it in this form. Yeah. It's all about the wording, to be honest. But yeah, I mean, technically a power series is something at the last one. Yeah. Okay, so I mean, I'm fine not completely getting through this, but I want to talk about like, so 4 we're basically already done, by the way, right? I'll do a different color here. This guy we already saw. This is the derivative. Well, this is negative the derivative of 1 over 1 minus x. So I'll probably have you do this as part of the class prep. And then we can like finish up the rest of this next time. So number 5, right, ln of 1 plus x. Instead of starting with ln, we know its derivative is a 1 over something, right? And so if you can do 1 over 1 plus x and integrate, that's how we would get there. And the last one is that we would want to talk about like how to multiply, because multiplying a whole bunch of terms, right? Like 1 over 1 minus x looks like this forever. And then you have to multiply by the negative one. So this and on forever. Multiplying two infinite things and like doing foiling there seems challenging, right? So there we have a way of using the fact that we know what the series look like and for the functions to figure that out in maybe a little nicer way. So that's stuff we can talk about on Wednesday. And yeah, I'm happy to answer questions. I mean, we're going into office hours now, so I'm happy to answer questions here, and then I'll probably like start bouncing to other servers if other people come in. But I'll have a video out later, like this evening probably. Yes, a lot of stuff does cancel. And you can either see it from that, or you can see it as 1 over 1 minus x squared, in which case you are plugging in an x squared, and so all the odd ones do go away. Oh, not the whole middle. So only every other term cancels, basically. Where's the worksheet on Canvas? So it's always under Files and then Worksheets folder. See you, Jackson. Unsubbed. Feels bad, man. Yeah, classwork folder. I'll be streaming Hearthstone until midnight tonight, so you can come on and watch. I was kidding. I'm not actually going to do that. I haven't played Hearthstone since Halloween, and I want to try to keep it that way. I'm really tempted. I was a legend once, Reese. Give me a break. I'm not streaming Fortnite. I have never played Fortnite, and I don't plan on playing now. I was a legend, literally, because it's Hearthstone and the top players are literally making legend. But also, I was very good. And you know that. But it's free, man. Hearthstone is also free. Free to play, pay to win, man. Sure. The new Animal Crossing. Never played Animal Crossing. Is it actually fun? Alright. Where do you want? Here? Cool. Then I'm definitely not playing it. Sounds terrible, man. Also, I'm pretty sure that I would be by far the best. Just due to like time spent playing video games. Yeah. This is why I got on Discord instead of Canvas chat. That and all the other reasons, because Canvas is terrible. I got 5 emails during that. Holy crap. I do want to become famous. Nice. Alright. See you later, Max. And yeah, you guys can always like just either say stuff in the text chat here or email me if you want me to like get an alert if you want to talk problems or whatever. But yeah, I'll be around at least for the next hour, but I might close out the stream. I would prefer to keep it remote for right now. Especially since I just got back from traveling, I don't think I have anything, but at the same time, I don't think it's probably the best idea to get in contact with me. And there was a confirmed case at UVA, so who knows? Hope I didn't play basketball with that guy. Or girl. Well, if it was a girl, I definitely didn't play with her, because they were all guys. Yes, homework is now due Wednesday, so I'll go ahead and change that now that we're finishing up. Get back on the normal timeline. Not necessarily. I mean, if you want to do that, then I will be definitely available during my normal office hours, as in like my literal posted office hours, not when I'm normally swamped by humans. Yeah, Caleb. So I'm changing that to Wednesday, and it'll now be online instead of on paper. But I mean, you can always email me. Again, I probably can't be as consistently around, but I will do my best. Because I think if I have everyone trying to do like 4 to 5, like to scramble before an assignment when I'm trying to do things online, it's going to be a freaking disaster. Because a crowded room versus a crowded chat room is a very different thing to deal with. Yeah, I feel you. I'm also not super excited for it, to be honest. I definitely enjoy the in-person thing. I mean, that's like kind of the point of Wabash, right? But I mean, you got to do what you got to do, right? Like it's true, like literally everywhere. Like I don't think any colleges are going on, so we'll figure it out. We'll do the best we can, and yeah. I mean, some things are hard. Spread the flag. I mean, this is like the most widespread one since what, like the Spanish flu, or at least yeah, more global than that, but like less death. Which is good. I hope to keep it as less death than the Spanish flu, since that killed like a ridiculous amount of humans. The real question is, what am I going to do with my life without the ability to watch NBA basketball? Or March Madness? Are you in Haiti? Here, I can end the stream, by the way. There's no real point in having that and just chat.